In this video, let's have a look at the other type of one sample test that we can have, which is a test on proportion. So the analogy, the logic is the same as a test on a mean. When we tested the mean, we wanted to see whether that mean differs from a certain value. In this case, we want to know whether a proportion differs from a certain value. And for the sake of the example, we're going to make it more practical. For instance, let's say that I would like to know what is the proportion of students at Erasmus University that watch my videos, because I make a lot of videos for them. So I'd like to know that data. And I assume under the null hypothesis that that would be 60% out of the students. So the proportion under the null hypothesis would be 0.6. But then I take a random sample of 74 students, for instance, and I find out from that 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 proportion is actually 70%. So do I have enough evidence that the proportion who watch my videos is bigger than 60%? That's the idea. I'm testing a proportion relative to a number. Is it significantly different from a number? So that would be the test. Now, what kind of test is a test on proportion? We're going to have a z-test. So we're going to calculate a z-value based on a difference. And that difference is going to be the difference between the sample proportion, so in this case it would be the 70%, p hat, and we're testing it relative to the null hypothesis. All the tests we're testing relative to the null hypothesis. So minus p under the null hypothesis divided by the standard error of this test, which is going to be the square root of p0, p under the null hypothesis, times 1 minus p0 divided by the number of observations. And the number of observations and the number are the total number of observations in the sample. So let's say the sample of students at Erasmus University that I'm working with, for instance, is 300 students. Out of 300, we want to see how many of them watch the videos. That's the idea. Now, this would be the test that we're dealing with. So this is going to be the z value. Now, based on the z value, what we said in the previous video as well, this is the standardized normal distribution, meaning it implies very large numbers. So when it comes to the critical values of the z distribution do not depend on the number of observations, do not depend on the degrees of freedom. It depends on the significance level that we're testing. So for the sake of the example, let's say that we're doing the test at a 5% significance level, and we can see that the test is one-sided. So the z critical value that we're going to use is going to be the z critical value with 5% significance level on one side only. So here we're going to have 0.05, and if I'm not mistaken, that value would be equal to 1.645. So we would compare the z value that we're finding with the z critical value and give a conclusion whether we're in the rejection region or not, whether we have enough evidence that more than 60% of the students watch the videos I make or not. That's the idea. What else is left for a test to understand? The confidence interval. How can we design a confidence interval for a proportion, and what does it mean? For the sake of the analogy, we'll make the same as before, 95% confidence interval. So the 95% confidence interval for the population proportion that we're interested in. That population proportion is the proportion of students that actually watch my videos at the Erasmus University, because there's a certain population at the Erasmus University. We do not have access to ask everyone if they do so. So we take a random sample and then we find some data from there. But that data, the proportion of the sample, is just an estimate of the real proportion in the population. So we want to give a range of values that's going to include the real value of the proportion in the population with a 95% probability. So that's based on the proportion in the sample that we find plus minus a margin of error. And the margin of error depends on the z critical value. So that would be the z critical value with 5% significance level, because 95% confidence interval implies 5% significance level, which would be 0.05 spread on two sides because it's a confidence interval, multiplied with the standard error. And the standard error in this case for the confidence interval would be the proportion that we are having in the sample times 1 minus the proportion that we're having in the sample relative to the number of observations in the sample under square root. And that's going to give us the confidence interval that we're interested in. And notice the analogy, the similarity between this test. Let me just zoom out to see it better. Between this test and the t-test is the same logic, the same steps. Hypothesis, we have a test, we have critical values, we can design a confidence interval. And based on the difference between the critical value and the real value, we're giving a conclusion whether we're in the rejection region to reject the hypothesis or not. Hope this all makes sense. In the next video, we're going to start working on the two sample tests.